Okay, so we are going to be looking at question 3 from your homework, which is the end of chapter test from chapter 3, and this which focuses on a car going over a bridge essentially. Okay, so you've got the car on the top of the bridge, there it is there, and it's moving with a velocity of a speed of 12 metres per second, and you've got a radius of the bridge, and the radius is 20 metres. Okay, you've got the weight of the car acting downwards, okay, which is W, and the weight of anything is mg, and then you've also got the normal reaction force acting vertically upwards, and we have to find out what the reaction force is in due course. Okay, so when we're looking at this scenario, the car is moving in a circle and therefore it's accelerating centripetally. So there is an overall force, a centripetal force acting towards the centre of the circle. Otherwise it would just move horizontally at a tangent. Okay, so our first part is question 3a, find the centripetal acceleration. And I expect most people are happy with acceleration is v squared divided by r, the velocity squared divided by the radius, which is 12 squared divided by 20, which comes out to be 7.2 metres per second. Okay, so that's the acceleration. And it's accelerating because it's changing direction, not because it's changing speed. Okay, so we're going on to part B now, which is an area of difficulty. Okay, so the way we deal with this is we think about the car at the top and the vertical forces involved in the car at the top. Okay, so we've got our acceleration, our force, our centripetal force acting downwards is ma. Okay, now ma is the weight acting downwards minus the normal reaction force, which is acting vertically upwards. So we can now substitute in, because we know a few things. So ma equals mg minus r. Okay, we can now rearrange that, so bring r over one side. R is mg minus ma. Okay, so we can factorise that, g minus a. We've already calculated the acceleration, we know what gravity is, 9.81. So our normal reaction force is the mass of the car, which is 800 kilograms, which is given in the question, times 9.81 minus our acceleration, which is 7.2. Okay, and then when you calculate that, our reaction force comes out to be of the order 2.1 times 10 to the 3 newtons. Now, part C is asking, show that the car will lose contact with the top of the bridge if its speeds exceed square root of gr. Okay, so for this we have to use a little bit of algebra, and we've got our initial equation here, which is saying that ma is mg minus r. Okay, so if we start with that, ma is mg minus r, but if the car loses contact, then r becomes 0. Okay, so this term disappears, so we have ma equals mg, but we know from our previous equation a is v squared divided by r, so mv squared divided by r equals mg, alright, but we've got m's on both sides, so they can be cancelled out, so you've got v squared divided by r equals g, So V squared is GR, so V is the square root of GR. Okay, and then so that's deriving that V equals the square root of GR. Okay, and then D, use your answer from part C to determine the minimum speed of the car. Okay, so here you're just substituting in. So if V is square root of GR, you know what G is and you know what R is, so therefore you can determine. So V is the square root of 9.81 times the radius of 20 metres. Okay, so when you work that out, that comes out to be 14 metres a second.